Maddie and Allie. We have a couple examples left to do on the bottom of 1-1 notes. So domains of functions and then an application problem. All right. They have different kinds of functions here ready to go for us. And a couple different things. We have this first one is just listing ordered pairs. This is in roster notation. Roster notation because it is just listing out the ordered pairs. Okay. But the rest of them, all of these are all functions. So we have like equations that we're dealing with finding domains of. Okay, so let's just worry about the first one, A, finding the domain of him. Okay, we have 5 different points. How do you find the domain of those 5 points? What will the domain look like for those 5 points? What do you got?
The domain is just the
X.
Just the x's, right?
-3.
And you have to put them in order.
-3,
so -3 is the first one.
-1, 0.
And they are in order.
2.
0, 2, and 4. And they don't ask, but is this a function or not a function?
Yes.
Yes, the x's don't repeat. Okay, now when we're dealing with functions though, there are 2-ish things that screw up a domain, and I call them domain errors. Domain errors, okay? You can't have a negative inside of a square root, or you can't divide by 0. That's the 2. Divide by 0, okay? Now, with an exception of one more thing, which we'll get to here in a second. So there's one more kind of, it's like a half of an error that you could have. So, but really those 2 things are what we're looking for. You can't divide by 0, and you can't have a negative inside of square root. So B violates one of those, okay? And so when we're doing domain, we're either saying what x can be or what x cannot be. So in this case, x can't be what?
5.
No.
-5.
-5. Because if I were to plug -5 in here, I would end up with 0 on the bottom. So x can't be -5. That's the domain. Okay, now, part C is getting into the half of a domain error, like the other exception to the rule. Volume of a sphere. We have volume equals 4/3 pi radius squared. Domain has to do with the input variable, usually the x, but in this case we don't have x's and y's, but which one would be the x? R, okay? Now, in this case, we look for our domain errors, negative inside a square root and division by 0. Do I have any of those things happening? We don't have a fraction, so we don't have to worry about 0 in the bottom. We don't have a square root, so we don't have to worry about that. So can this be all reals?
Yeah.
No,
Kind
it
of.
can't be next to
It's
0.
all reals except, I'm not going to say all reals except. I'm just going to say R has to be what?
Greater than 0.
Greater than or equal to 0. It could be 0, in which case that would be kind of silly.
Wait, why can't it be?
We can't have negative radius because radius is length. Okay, so
But
that is the exception to the rule for domain errors is when you have story problems. Okay, story problems are the only exception to the rule because when you have story problems and you're dealing with like length and radius and things like that, you can't have negatives. Okay, so that's the only other thing that you have to take into consideration. Okay, so in this case, the domain is that the radius has to be greater than or equal to 0. Done. Okay, D, 4 minus x squared. This one's a little bit harder to deal with. Okay. This domain error has to do with a negative inside of a square root, and this one has kind of steps to do it. Okay, are you ready for the steps? The first thing that we're going to do when we're worried about negative inside of a square root is step number 1, we're going to set inside equal to 0. Okay, we're going to set the inside equal to 0. So we have 4 minus x squared equals 0. Yeah? And then we solve for x. Okay? So I'm going to add the x squared over. So 4 equals x squared. And then take the square root. And it's plus and minus 2. Okay? Set inside equal to 0. Step number 2, solve. And then step number 3, find the solution intervals. Okay, here's how you find the solution intervals. We said 2 and negative 2 were places where crazy things were happening. Like negative 2 is here, positive 2 is here. And I'm going to try to plug numbers into the 4 minus x squared. I think we've done this before maybe, right? I know we did. We just got into doing it in trig. All right, so let's plug in like negative 3 here. Always plug in 0 if you can. Plug in positive 3 here, and let's see what we get. Okay? So if I plug in negative 3 inside of here, negative 3 squared, this would be 4 minus 9 and the square root of that.
It's negative.
Bad. Bad, bad. We can't do that. Now, what about a positive 3? If I did the positive 3. Same thing. Bad. If I plug in 0, though, 4 minus 0 squared, I can still do that, right? So, our domain is I am only allowed to plug numbers in between negative 2 and positive 2. So, the domain of this guy, we would say, I'm running out of room here. The domain, negative 2x is less than or equal, or is it equal to? Can we be equal to 2 and negative 2? If I was equal to 2, this would be like 4 minus 2 squared. So 4 minus 4, which is 0. Can you take the square root of 0? Yeah. Yes. So this is going to be my domain. Does that make sense?
Mm-hmm.
Yeah? Okay, so when you have a square root, that domain error is a little bit harder. This one is a hard domain error. This one is a kind of an easy domain error. When you're dividing by 0, it's easy just to look at that number and say x can't be 5. Versus this one, you kind of have to think a little bit harder and do a little bit more work. Okay, so x can only be between negative 2 and 2. Yeah?
Mm-hmm.
What about e? What can x be and what can x not be? Look at your domain errors. Division by 0, negative inside a square root.
It can be anything.
It can be anything, and it's not associated with the story problem, so all reals for that one. Part E, I can plug in anything I want to in for x, and he will work, so his domain is all reals. If you think about the graph of this thing, he's a parabola, wherever, right? And domain is saying left and right. Will he go to the left forever and to the right forever if he's a parabola? Yes. So all reals for that one, okay? All right, application problem. A baseball is hit at a point 3 feet above ground at a velocity of 110 feet per second at an angle of 45 degrees. We don't care about that information because, nope, we don't care. Because it says the path of the baseball is given by this function. So this is taking all of that into consideration. Okay, so we don't care about the first sentence because they've given us an equation for it. All right, I'm going to write that down below here. F of x equals negative 0.0032x squared plus x plus 3. Okay, where x and y are measured in feet. Okay, what is x representing and what is y representing?
X's domain, R is range.
X's domain, R is range, but what does it mean? What is the x and y meaning?
X is feet.
Yeah, they're both in feet.
Oh.
So this is feet and feet, but what's the difference between the two? The x and y, this is y. The x and y are both going to be distances, lengths, right, in feet.
So the one's going to be what you're trying to find, which is whatever it says.
Right, right. Well, what's the difference between x and y? We're talking about the path of a baseball. The path of baseball is path of the baseball is doing one of these, right?
How high and how far?
This is the horizontal distance in feet, and this is going to be the vertical distance. Does that make sense? X is horizontal distance, the y is going to be vertical distance. Both of them are in feet. Okay? It says, will the baseball clear a 10-foot fence located 300 feet from home plate? How do you want to do this? Plug in what?
10 for y.
No, plug in 300 for the.
I'm just going to plug 300 in for x and see if it comes out to be a number bigger. We're just going to compare it to 10, right? So 0.0032x, no, not x. X is actually 300. 300 squared plus 300 plus 3, and I don't know what that is. 0.0032 times 300 squared plus 303.
Thing.
And it says, how high does it go?
Well, I think mine is wrong.
Your battery is low.
Mine says 591, but that
Ooh.
is far off.
Ooh, did you do a negative
No, I did not.
in front of the point
That's
0.0532?
What are you doing?
I got
15.
15. So will it clear the 10-foot fence?
Yes, it will.
You betcha. Yes. If that's the
Yay.
path traveled by the
Alright.
baseball, it is 15 feet in the air by the time it's 300 feet out. Okay. So 15 feet in the air, he will clear the fence. Yeah, good. Okay. All right. Tomorrow I'm gonna be gone. If I give you a day to work, will you utilize it?
Yes.
Are you sure?
Yes.
Yes.
Indeed. Okay. All right. Did you girls hear that? You can't answer me. Sorry. On the video, I'll give you a work day tomorrow.
I can do stats.
Okay. You can, and you can
I
do stats,
also will-
and you can do trig, and you can do calc, and you can do all
I
of
will
all of
likely
the
not be
things.
in here on Thursday though.
Oh no!
What?
I'm not gonna be here tomorrow.
So then you get a work day. You're fine. Yeah, because you're a junior. Ha 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 ha. Okay. All right. Goodbye, girls. Watching this video.
Yes.